Well, good day everybody and welcome to today's webinar, which is Easy Creation of .NET Symbols for Smart 3D. My name is Andy Osborne, I'm Director of Global Business Development, and I'll be joined today by Daniel Dolinsky, who's our Lead Business Process Architect. So in terms of the agenda, we're going through this brief introduction. We're then going to go on to sort of a general overview, only very short. We're going to save most of the time for the live demonstration, where we're going to cover symbol development, creation of .NET VB code and bulk load sheets, and loading symbols into Smart 3D. That will then come back to me for a summary, some poll questions, and then we'll go on to answering any questions that you have. So as we go through the presentation, please feel free to put any questions in the question panel and we'll save them up till the end. The overall event should take around about 30 minutes, depending on the questions. We will be recording it and making that recording available to you in due course. Okay, so without saying any more, I'll move on to the brief overview. So if we consider custom symbol development, we start off typically with a blueprint of the type of symbol that we want. Now, to load that in, we need two things. We need a bulk load datasheet, and we also need a project to create the DLL, and that typically has been VB in the past. Now it's VB.net. So once we have those, we can then load them in and then use them within Smart 3D. So really what we're talking about today is using 3D SymbolDesigner, which can create the symbol graphically. It then generates the bulk load file and the code so that you can load that into Smart 3D. So this is the typical user interface, and I'm not going to go into any great detail, but needless to say, we're building the custom symbol out of primitives that are available to us in this top menu. Daniel will go and explain a little bit more about what each of the elements does as we go forward. Of course, having done that, we then generate the various code that we need and the bulk load sheet. And of course, you can use it for many different types of symbols, so whether it be equipment, piping, HVAC, hangers and supports, it's entirely up to you. So these are just some examples that have been done in the past. Okay, well, I did say it was a very brief overview. So what I'm now going to do is hand over to Daniel, and hopefully Daniel is there, and he's going to carry on with the live demonstration.
Yes, I'm here. So hello, everybody. I hope you can hear my voice and see my screen. So I'm going to show you a live demo of 3D SymbolDesigner. I think we have a lot of customers of this product in this session. So the big question is, what's the difference between 3D SymbolDesigner output to VB and VB.net? So the answer is very simple. Build up your symbols as usual, and then finally, when you do the export, you can select the export to Smart 3D as a .NET symbol, and you can export to a VB6 code. So let me just show you what happens when you export to .NET. So that's for the classical storage tank assembly, where you get code looking like this now. So it's very similar to the samples that we get from Intergraph. As you can see, we have a list of errors here. So that's the first step I want to show you. We've got a new chapter in the documentation about .NET symbols. And so, as I said, build up the symbol as usual, but then select the .NET export instead of Visual Basic. And then open up the Visual Basic file. So that's the step I've done here. And then there is some local thing you have to define the path to your local Intergraph DLLs. So in this case, that's my local path here. And so this is quite easy, and I think you can just look at the recording to go through these steps. Double-click my project, go to References, and here it can't find the intergraph files. So go to Reference Paths, add the folder name, and that might be different depending on your system, depending on the installation of Smart 3D. So you just add this reference path and then push OK, and that's it. All the error messages are gone, and then you can just rebuild the DLL. And when we look into the directory here, then we can see the result. So we have an object directory debug, and in here we can see the DLL. And that DLL needs to be copied to your symbol share. So it's on the next page here in the documentation. So copy it to the symbol share, and then go to your project management and update the custom symbol configuration. So I will also show you this button. So that's project management. Go to the catalog where you want to add the symbol to, press the right mouse button, and then update custom symbol configuration. So that's the new thing. And it all starts at the export of the symbol. Everything up to the export, so the build-up of the symbol is identical to the VB6 code. This means you can just open up old 3D SymbolDesigner projects where you created VB6 symbols, and then for the export, just go here. On the second tab, on the Build tab, select visualbasic.net. That's all. So that's the only difference here in the user interface. Everything else stays the same. Now for new users, or if you didn't see this software before, let me just explain how 3D SymbolDesigner itself is working. I will just build up a small example. It's a little tank symbol, and I will go through the steps that are needed here to build up the sample, and it's always the same workflow. So no matter if it's for equipment or piping or hanger and support parts, it's always the same workflow in here. So after you download the software from our website and you install it, which usually just takes a couple of minutes, and you run the tool, it looks like this. So we have a preview area over here where we can see a preview of the symbol. Then we have a tree view on the right side with the logical structure of the symbol. And down here we have a list of variants. To build up a little tank, first of all I need some geometric items. So I can press this button here, which adds a cylinder to the preview window and also cylinder 1 node over here. Again, the workflow is very similar for all items. So we have a geometry node. In this case, it contains the diameter and the length of the cylinder. And we have 2 nodes to rotate and translate this object. Again, same workflow for all the objects. So I added 1 cylinder, and let me just switch to the wireframe view so we can see what's happening there. I add now 2 spherical segments for the tank ends. So I press this button twice, and I got 2 new nodes over here in the tree view. And of course I need some input parameters for the symbol. So I select the parameters node, and I press this button twice, which adds 2 columns to the list and 2 parameters to the tree view over here. I can now rename these parameters. So this one could be power vessel length, and the other one could be power vessel diameter. As you can see, also the columns down here got renamed. And I can create several variants of the tank symbol. So perhaps tank A, and then I just insert 2 additional variants, tank B and tank C. And I modify the values over here. So you can mix unit systems. So whatever is on the data sheet, just enter it here. So we might have a length of 2 meters and a diameter of 1 meter. and perhaps we have a second variant where we have a length of 12 feet and a diameter of 6 feet, and perhaps it's mixed, so we might have 3000 millimeters and a diameter of 42 inches. So whatever is on the data sheet, you can use it in here. When I select one of these variants, the values get copied to the tree view over here, and these nodes can be used to make our items up here parametric. So I can just drag and drop the vessel diameter to the D1 node and the vessel length to the L1 node, and the cylinder resizes immediately. And then I can open up the spherical segment 1, where I just drag and drop the diameter of the cylinder to the diameter of this one, and I drag and drop the diameter to the radius. I open up the formula, and when I do the drag and drop, it just copies the name of the source node into the formula of the target node. That's all. So I could also enter this manually, or in this case, I just modify the formula, so I divide the diameter by 4, so I get a nice tank end at this position, which I rotate about the Z-axis by 180 degrees. So I have a degree sign on the German keyboard. If you are using, for example, a US keyboard, just use DG instead of the degree sign. That's also fine. So now we have a left tank end, and now I just need to copy the formulas or link the formulas of the first spherical segment to the second one. So I drag and drop the diameter and also the radius, and then I translate this to the right by power vessel length. Basically, that's it. That's the workflow how we build up symbols in here. So we have now 3 variants, tank A, B, and C. And as soon as I select a variant here, the values get copied to the formulas over here. So everything you have seen so far could be done by junior engineers. You just need to know about engineering, master a little bit. But basically, you look at the drawing, you decide what parameters to use and what bodies you want to place in here. So the final steps to get this into Smart 3D should be done by senior engineers who know about the Smart 3D catalog. It's the parameter mapping and selection of the target nodes in the catalog. And of course, at the end, modification of the bulk load files. I do the mapping down here. So as you can see, I get a red highlight. So I have no correct mapping at the moment. So I know we have attribute name called vessel length. So I can enter this manually, but I still get the red highlight. So I can use the context menu to get the interface name for this one. So there's just one interface available. And so I can press apply. And I want to have this as an occurrence attribute. As you can see, I get the green highlight. That means we have a correct mapping down here. I can also enter mappings manually. So I know that we have a vessel diameter attribute, and it's located on the user interface vessel diameter. So that's the way to do this manually. If you know what interface and parameter name to map to, you can just enter this manually. So that's the workflow in here to build up symbols. We have a lot of additional objects. So for example, it's possible to place nozzles and other connectors. So let's just place one piping port on top. So what I do is I place a piping connector, which is asking for a piping port. A port is always a collection of parameters. So we get the real values from Smart 3D when we try to place the object at the end. So we can go to this button and add a piping port with a bolted preset. But the real values come from Smart 3D when we place it. So as you can see, it placed this nozzle shape, and I can now modify the piping connector. So perhaps we have a length of 100 millimeters in here. And I rotate this, so it's looking upwards. So I would just enter minus 90 degrees in this formula. And then I translate this upwards by par vessel diameter divided by 2, which is the radius, plus 90 millimeters. Sorry. And I move it to the right by par vessel length divided by 4, which places this at a quarter of the length of the tank. So that's all. It's now placed on top of the tank at a quarter of the tank length. And we can now just save this project. As you can see, it's saved in an Excel file, so we have an open file format that can also be used to modify it by external tools. And I can export this to Smart 3D. So I press this button up here. I go to the catalog, I select Equipment, Process, Horizontal Vessels, and in here I add a new node. I select this node, so that's the target node for the catalog position. The important column is this one over here, so it's the part class type. Because I selected a node somewhere in the equipment tree, the system assumes I want to have an equipment assembly class. In this case, of course, it's fine, but I could also export to other part classes. Then I go to the Build tab, and now we have to decide if we want to have VB6 code or Visual Basic.NET code. So I select the second option. I go to Browse. I create a new folder. Call this NetTank sample. Press OK. So that's the folder where I want to place all the export files. And then I press the Start button. And that creates me, and it's already done, on my desktop, a folder NetTank sample, which contains the VB project and a bulk load file template. So let's open up this Excel file. As you can see, it was created just a few seconds ago. I got 3 variants in here, tank A, B, and C. So that's also difference compared to the VB6 output. As you can see, we have a different definition of the symbol definition and of the definition down here in the list of variants, and also up here in the global symbol definition. So that's the new style that is needed for the .NET symbols. Everything else is like in the old outputs for VB6. So we have the 2 parameters here. We specify the catalog roots. In this case, it's equipment. This goes to a process, and we add a new part class called MyTankAssembly here to the horizontal vessels. We are using 2 attributes, including their interface names, and we have an empty GUIDs tab that gets filled during the bulk load. So that should be okay if you want to try the geometry on a test system. So you can just place the DLL as described on your symbol share, do the update in the Management Studio, and then you would just bulk load this file. Of course, if this has to go to the real catalog, you have to modify this, which should be done by an experienced engineer again. So of course you would modify the process EQ type, mirror behavior option, and probably the part description and so on. That's the reason why we have this label up here for the real catalog. Modify the parameters as needed. So what is the result in Smart 3D? It's just a normal symbol. So you can use this like all the Intergraph symbols. So we have some samples here done with a new .NET version. So there is no real difference in the symbol. And now I want to show you in the last 5 minutes other nice features in 3D SymbolDesigner that make life easier to you. So create a new project. Another nice option in here is a so-called for loop. So I add this for loop by pushing this button up here. And that's like a programming for loop. So if you know a programming language, there's probably a for construct somewhere in this programming language. So in this case, we can go from 0 to 35, for example. And now we get 36 copies of whatever is in the geometry node over here. And I can easily place a cylinder in this for loop by just dragging and dropping the items from the main folder here into the for loop. So I get now 36 copies of the cylinder. Let's just resize it a little bit. So perhaps the diameter is 12 millimeters and the length is 100 millimeters. So it's looking like a bolt. Now I can go to the translation nodes and I open up the Y translation. I enter a sign of this for loop 1. So this is geometry dot for loop 1 times 10 degrees times, for example, 0.5 meters. Let's just copy this formula to the clipboard, and I reuse it for the set translation where I change the sign to the cosine. So I got now a circle of 36 bolts just with a for loop and a cylinder. So very easy to create complex geometries in 3D SymbolDesigner. And again, it's also easy to make this parametric. So let's just add one parameter here. I go to the properties where I can change the display to a number. So I want to enter the number of bolts. Then I enter 36 down here. And I use this parameter 1 for these formulas over here. So I can use a parameter 1 minus 1 in here. And then I go to my translation node where I use 360 degrees divided by parameter 1 and also go to the set translation here. I reuse the formula again. I change the sign to the cosine. As you can see, nothing has changed. But now when I go to my parameter over here and, for example, I enter 6, I get a circle of 6 bolts. If it's 5, it's a circle of 5 bolts. Or I could also just use 70, then I get a circle of 70 bolts. I hope that you got a first impression of the workflow in here in 3D SymbolDesigner, because it's always the same workflow. I can make my formulas dependent on parameters, the formulas dependent on other formulas, and I can use for loops and other objects like unions, for example, to group and copy objects. So it's very easy to build up complex geometries. Plus, I can add a lot of ports and connectors like cable tray, conduit, piping, that's what we've seen in the tank example, foundation port, HVAC, hangers, and additional objects like datum points, for example, for equipment, or dummy operators for piping, where I can replace this dummy operator by any intergraph operator or operator that was built up using 3D SymbolDesigner. And of course, some additional objects like center of gravity, which is often used for hanger and support parts, or for example, control points. That's it from my side. Was a quick introduction into this product, and I give back the control to Andy.
Okay, thanks, Daniel. Right, let me just switch that back. Okay, so what I want to do now is just go on to the sort of summary. So what you've seen really is you've got easy placement of objects in a graphical user interface, and as you're building it, you see exactly what you're getting. So what you see is what you get. Feedback we've had from clients is that we do see an 80% reduction in man hours for the creation of symbols if you compare that against manual coding methods. Most symbols can be created without the need for any programming language, but clearly if you're looking at hanger and support assemblies, you will need some programming knowledge, because you will create the individual parts using the 3D SymbolDesigner, but then you'll effectively glue them together with the assembly code. So what we're seeing is time savings, because you're automatically creating the bulk load sheets, the Visual Basic .NET source code, and the symbol documentation.